Good day to you, children. It is time for 12.2, Arithmetic Sequences. So an arithmetic sequence is a sequence where we have a constant difference. It's going up by the same number or down by the same number. Okay? Now, we can define this recursively, where we could have a sub 1 as our first term here. And then to get our common difference, we would take one of those terms and subtract the previous term to get that common difference. So a sub 1, where a is some real number, and d would also be some real number. And then we'd have a sub, and then we'd have n minus 1, the previous term, plus our common difference. Whether that common difference is positive or negative, that's what we're adding to the number. Okay? We'll do some examples with this here in a sec. All right. So the number a, which is a real number, that's the first term. And then d, that's our common difference. Lovely. All right. So that's it. We take the previous term, add the common difference, whether that's positive or negative. We'll get the next term, so on, so forth, continuing on. So let's see here. First, I want to show the sequence as arithmetic. Well, I can see I'm going down by 2, and I'm doing down by 2 again, and down by 2 again. Cool. That's arithmetic, right? It's the same difference each time. My first term is 4. My common difference is negative 2. All right. So what's my recursive formula for this one? Well, I would have a sub n is equal to the previous term plus my common difference. In this case, it'd be plus negative 2, so minus 2, where, and I'm going to run out of room here, a sub 1 is equal to 4. So that would be my entire formula there, defined recursively. You may see some write plus negative 2. I prefer the just minus 2. Okay, I feel like it muddies it up when you see the plus negative 2. To each his own. All right, next one. Right now we have 4n minus 1. So that's actually defined explicitly, but we could list out some of our terms here, or our numbers here. We could have s sub 1. If I put 1 in for n, that'd be 4 minus 1 is 3. S sub 2, that'd be 8 minus 1 is 7. And then we'd have 11. And then we'd have 15. We're going up by 4 each time, aren't we? Okay, so the common difference is going to be 4, right? And my first term, my a sub 1, that's going to be, or sorry, s sub 1 in this case, that's going to equal 3. All right, not too bad. So defined recursively, I'd have s sub n is equal to the previous term plus my common difference, where s sub 1 is equal to 3. Like it. It's awesome. Awesome sauce. Very cool. I just use s here because that's what it started with. The next one starts with t. My goodness. It's like we could just choose random variables. Because we can. Sometimes we have reason behind them. All right. You can pause it, try it on your own. I'm going to pause it, write some things down. That way we can save a little time. Time is money. That ain't funny. So you got my terms listed out here. negative 1, negative 4, negative 7. It's going down by 3 each time. So your common difference is negative 3. T sub 1 we see is negative 1. So I'd have, almost did a, T sub n is equal to the previous term, T sub n minus 1, plus my common difference, which would be minus 3, where T sub 1 is equal to negative 1. All right, now we got our nth term of an arithmetic sequence theorem. All right, so for an arithmetic sequence, we can write actually a different formula here where we're not defining it recursively, we're defining it explicitly. Okay, so we're going to take our first one, our first term, a sub 1, and then we're going to add, we're going to have n minus 1, the term number, minus 1, multiplied by my common difference. Okay, now some people like to write this out a little bit differently. I'll talk through that with some examples. You could use this direct formula here, or some like to think through it with their first term. I'll explain what I mean with an example here in just a sec. All right. So jot that down. It's an important one. Yeah, we'll give it to you as well. You see highlighted in yellow. Whoop, whoop. All right. So Find a formula for an arithmetic sequence, and then find a particular term of an arithmetic sequence. That's what we're going to do right now. It's going to be awesome. All right, find the 24th term of an arithmetic sequence. Well, as we can see here, it's going up by 3, right? Each time it's going up by 3. So I already know my common difference is 3. And my first term is -3. Lovely. Wonderful. All right, so we could plug this all into our wonderful formula here. A sub n is equal to -3 plus n minus 1 times 3. All righty. Now we can simplify this all down, which I prefer to do because it's a little messy right now, right? It's a little messy. I'd have -3 plus 3n minus 3. Let's combine some like terms. So my final will be a sub n equals 3n minus 6. Oh, it's real nice and clean, right? That looks good. Okay. Now, what some people will do is they'll just jump right to this formula. They'll say, okay, well, I know my common difference is 3, so it's going to be 3n. Now, how do I get that first term? I need to, if I plugged 1 in for n, I'd get 3. So I'd have to subtract 6 to get that -3, that first term. So they'll just jump right to this simplified form in that way, okay? So you can go ahead and do that if you'd like. If not, and I'll show that in maybe one of the next examples to how I would do that without seeing it right away. But now it says, what's the 24th term? Let me change colors here. So we want a sub 24. So I'll just go ahead and plug 24 in and evaluate, right? And I'll end up getting 66. Yeah, because that's going to be 72 minus 6 is 66. Boom, done, awesome. America. All right, not too bad so far, right? It's not too bad. It's good stuff, fun stuff, awesome stuff. Let's move on. All right, find a formula for an arithmetic sequence. This is kind of interesting. The 6th term of an arithmetic sequence is 26, and the 19th term is 78. Find the first term and the common difference. Okay. Take a deep breath here. So the 6th term is 26. So a sub 6 is 26. And the 19th, that's 78. Okay. So how much is it changing each time? Change. That sounds like slope to me, right? Which would be changing y over changing x. So our function values here, the 26 and the 78, that's like our y's. And the n's, that's like our x's, right? So if I did 78 minus 26 divided by 19 minus 6, that's going to give me my common difference, right? And we write these out. They look like they're in slope-intercept form, the common difference being your slope, okay? Now, if we do some calculations here, I believe we'll get d equals 4 for my common difference. All right, lovely. So you get 4 for our common difference. Now, what's my first term? How am I going to get my first term? Well, in that previous formula, and this is why I do like knowing this formula. You don't want to get rid of this one, even though you can do how I was talking about, like go right to this guy right here. This one's still helpful here in this situation. So check this out. If I've got this formula, a sub n equals a sub 1 plus n minus 1 times d, I know my common difference. It's 4. The term I know, let's say I know the 6th term, right? So n could be 6. I don't know my first term, but I know a sub 6, that's 26. So I can set up this equation and solve for my missing term, right? Just like a normal algebra 1 kind of equation in this scary looking world. So I've got 26 is equal to a sub 1 plus, that's 5 times 4 is 20, subtract, and I get 6 is equal to a sub 1. So I've got my first term and my common difference. I've accomplished what we want for part A. So the next part here is give a recursive formula for the sequence. Well, I know I've got the a sub 1, so we're already good there. So it's going to be a sub n is equal to the previous term, a sub n minus 1, plus my common difference of 4, where a sub 1 is equal to 6. That's it. I already did all the heavy lifting, right? I already did all the work. Now it says, what is the nth term of the sequence? What we're looking for is this explicit form, as it will be referred to in the future. Now we can do a couple things here. You can write out in that one formula, or we can go right to it. Okay, I'm going to show you how I go right to it. So a sub n is equal to, my common difference is 4. I know that. So I know it's going to be 4n. How am I going to get 6 for my first term? Well, if n's 1 for my first term, 4 times 1 is 4, plus what gives me 6? Plus 2. There's my nth term. Now, if you don't like doing that, it's okay. You can go about it in the other way that we did first, where I'd say a sub n is equal to a sub 1, which is 6, plus n minus 1 times the common difference of 4, and then just simplify. So I'd have 6 plus 4n minus 4, combine like terms. 6 and negative 4 gives me 2, so 4n plus 2. And we get the same answer, just in a different way. Your choice. I don't care which way you go. It's up to you. I'd like to show you both ways, though. You know, it's helpful. Your minds can handle it. I don't know what that was. Let's keep going. All right. Now we're going to find the sum of an arithmetic sequence. So we can add them all up, right? Now, why would that be useful? Well, let's just say, we'll have an example like this here in a little bit. Let's just say, I like this one. You're in a stadium, right? Most of us have been there or have seen one, right? In the corner, the seats go up a little bit more, or in like our PAC or whatever, the seats increase each row in one of those corner spots, right? Well, let's just say that they increase by 3 or 4 or 5 seats each time. You would know the number of seats in each row, and you could define that with an arithmetic sequence, right? I could say, oh, it goes up by 4 each time. It starts with 40 seats in the first row, and now by whatever row, I know this is how many there are going to be. Well, what if you're the person that's ordering the seats for that entire section? You'd want to add up all of the rows. What if you have 50 rows? You're going to add up 50 numbers all together. There's got to be a simpler way, probably a computer program. But we're going to do it with summation, okay? So there is a nice little formula for this as well, but that would be the use for it. And I like to have a little bit of use for it, a little context as to why the heck we're even learning this. All right. So all we're doing is we're adding up all of our terms, okay? So I feel like I don't have enough room right there. I'll write it over here. So if I start with k equals 1 all the way to n, and then I'd have my formula defined here, a sub 1 plus, and it would be k minus 1, since we're starting with the k down there, right? Times d, close my parentheses, or brackets if you'd rather. Okay, we could do brackets if we want a different grouping for the outside. So I'm going to pop my formula in that summation. You can plug that into your calculator if you'd like. You can list them all out and add them. That seems like a lot of work. There is also a formula for this, okay? I'm going to do it over here on the right-hand side. So this is going to be n divided by 2 multiplied by the quantity of our first, the sum of our first and last term. So I do need my first term, and I need my last term. And we're not always going to have all that information, of course, right? We're going to give you weird things. You have to think through it. But you need your first, your last term, and the number of terms, obviously, because n is part of that formula. So those are the 3 things that you need to know. The number of terms, the first term, and the last term. Okay? Jot that formula down. That will be helpful here, but it will be given. Okay? Awesome solves. So find the sum of the first n terms of this sequence. So just asking for the first n terms. It's leaving it kind of generic. But let's go ahead and write some of these terms out. So let's say a sub 1, that's going to be, 6. A sub 2, that's going to be 8 plus 2 is 10. It's going up by 4 each time. So then 14, 18, so on and so forth, right? Okay. So let's see here. So the sum of some number of terms is going to be n divided by 2 times my first plus my last. But actually my apologies, would be that 4n plus 2. Let's ... A sub n would be 4n plus 2. However many number of terms would be, that's what I'd have. If I had 100 of them, That'd be 4 times 100 is 402. That'd be my last term. Okay? Cool. Almost made a mistake there. Whew, caught myself. It happens. It happens to all of us. All right. So now, all right, we got that. I feel like we could simplify that. Don't you? I feel like we could. So I'm going to combine some like terms. So I'd have S sub n is equal to n over 2. And then I'd have 4n plus 8. And I could distribute in, so I'd get, that'd be 2n squared plus, and then 8 over 2 is 4n. Right? Okay. Cool. I like it. So let's say it was the first 100 terms. I already said the 100 before, right? So let's say we want the first 100 terms. It'll add all of them together. So I would have 100 squared plus 4 times 100. Forgot a 1. All right. Plug that into my calculator. There's going to be some decently, I guess you could probably figure it out. You'd have like 10,000 times 2 is 20,000 plus 400, so 20,400. There we go. So that'd be the first 100 terms now. This would be the first n terms. The sum of the first n terms is this right here. And then I just did a side example of 100 terms, so we had just a finite number, right? Okay. That was cool. Let's do part B here. This one looks interesting. Find the sum of that. Now, I don't know how many terms we have. Get that dot, 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 right? I don't know how many terms there are. I do know what my first term and my last term are, though, right? That's cool. So what if we did this? Just so we have like some end goals here. I'm going to jot this all the way down to the bottom here. S sub n is equal to, we'll replace that n with something soon. N over 2. Again, we'll replace that n because we don't know how many terms there are. But I do know my first, and I do know my last. But my goal is to find n right now, right? The goal is to find n. Okay, let's see here. I do have a formula for this. A sub n is equal to a sub 1 plus n minus 1 times d. I know my nth term, if we go with my last term here, because I want to find out how many terms there are to that 122, right? So if I set this equal to 122, if I solve for n, that would tell me the number term that 122 is, which is the total number of terms. All right. Well, a sub 1 is 52. 52 plus 5 gives me 57, plus 5 again gives me 62, plus 5 again gives me 67. So our common difference is 5. I've got everything that I need to solve this. So let's solve it. We could combine some like terms. So let's do a little algebra here, shall we? We could subtract 52 right now. I'm just looking at that because I see the 2's and the 2's, right? That's kind of nice math. So what do I have then? 70 equals n minus 1 times 5. Cool. Then if I did 70 divided by 5, rather than distributing it, because I know 70 is divisible by 5, I'd get 14 equals n minus 1. Add 1, I get n is equal to 15. So there are 15 terms here. I can now replace 15. S sub 15, right? Sum of the first 15 terms is what we're saying there. So now we can plug that into my calculator, 15 over 2, or 7.5, multiply by that sum, which would be 1305. 1,305. That's awesome. We got uno mas problem here. Uno mas. Are you guys ready for some application? I am psyched for some application. Oh my goodness, it's like what I was talking about at the start of this video. All right, so the first row of seats in a corner stadium section has 20 seats, and there's 40 rows in the section with each row having two more seats in the row in front than the row in front. Okay, I stumbled through that terribly. All right, so we're starting with 20 seats, and we're going up by 2 each time. In those corner stadiums, the corner of it kind of look like this, right? So I've got 20 right here, front row, except for in the corner. So, yeah, it's still cool. And then we got deuce, deuce, 22. Then we've got 24. Then I got 26. Should I keep going? 40 rows? I feel like that's just a waste of time. Perhaps I can math it up and figure some things out. I think we can. There's going to be 40 rows, okay? So if we think about when it says how many seats are in that section of the stadium, I want to know what the sum of all of those seats are. And I've got a sum formula, S sub, 40 rows. I know what N is equal to 40 divided by 2 times my first row, which is 20 plus, the last row is what I need, right? A sub N. That's what I need. I need the last row, or A sub 40 in this case, is what I need. All right. Well, perhaps there's a way to figure this out. It's going up by 2 each time, right? D is 2. Okay. And the first row is 20. So A sub 1 is 20. I could probably set this up, right? So let's see here. A sub 40 is equal to, we could go with, sorry, not 2. Well, yeah, 20. Could use the 2. 40 minus 1 times my common difference of 2. Nice. Plug that all in. I've got it worked off to the side here. We've got ourselves 98. 98 seats in that final row. So, pop that guy over here. And we're going to plug that all into our trusty TI-84 calculator. I've got 40 over 2, or 20 times 20 plus 98 in parentheses. 2,360 seats in that section. So if I'm the dude that's ordering that stuff, yo, Super Seats Unlimited, I need 2,360 seats for the corner of this stadium that I'm building. Okay? And we're done, right? I don't know. I wonder who would be selling those seats. It's got to be some celebrity. All right. Anyway, guys, hope you enjoyed it. Had some fun here. Saw some use for it in the real world, even if you're not going to be ordering seats or whatever. But hey, it does apply, right? It does apply here, and there are many other situations, but this is the one we'll do for today. Have a wonderful day. America, freedom, rock and roll, Costco. Yo-ro, right? You only round once. It's not yort. You only round twice. It's once. One time. Very end. Riverdog Janie on the gram. Deuces.